In this video, we will learn how to perform analytics for univariate quantitative continuous data in Python. Let me show you the data files that I've created for this purpose. I have a file called univariate data quant continuous small.csv, and it has data for 25 order amounts. So order ID is just my label field, it's not data field. So I have one quantitative column of data called order amount. I have 25 order amounts. Now one can easily perform analytics on this data in Excel. We really do not need Python. But when the data file gets larger, so here I have univariate data quant continuous median. It has 1,000,000 records. See, the last record is 1,000,001, and first one is just data labels. Now, even this one, we can open this file in Excel and perform analytics because Excel can handle little over 1,000,000 records. 1,048,576 is the number of rows in Excel on a sheet. But what about this file? This has 4,000,000 records. There's no way you can even open this file in Excel, let alone perform any analytics on it. So when we are confronted with big data like this, so we need a different tool, one that can handle large data. So Excel is a great tool, but it has its limitation on how many rows you can work with at a time. So let's write some code. In step one, we will read the CSV data file using pandas library as a data frame. So we first import the pandas library as PD, and then we will create a data frame df by using the pandas function called read CSV, and then we provide the name of the data file, which is univariate data quant continuous small.csv. So this will read the entire data file in a variable called df, which is a data frame, which is really a table of rows and columns. It has two columns, order ID and order amount. So we're really not interested in order ID, we're interested in order amount. So we will create another variable called order amount data, which is part of this data frame. What part? The one with the label order amount. So I'm typing this word order amount exactly as it appears in the data file, order amount. Okay. So just to see if we have successfully read the data, we will print order amount data and see if our code works this far. So I'm going to save this file as analytics for univariate data quant continuous, and I'm going to run it. And you see here, I can see that it has read the data. Let's see. Our first order amount is 2639.24, 2639.24, and the last one is 1474.23. Okay, so now that we have successfully read the data, we will do step two. Step two is to perform descriptive analytics. So what does it mean? We'll compute mean, median, mode, standard deviation, etc. So mean value equal to order amount data dot mean. So mean is a function that applies to this list of data called order amount. And then we can print it, mean, order amount, mean value. So let's see if this is working so far. So I save the data file, I run it. There it says mean order amount 1092.0752. We can say equal to, and if we want it to show only two decimal points, we can round it to two decimal places. And let's save it and run it there. Similarly, we can calculate the median value. dot median, and we can print it. So instead of mean, we have median order amount, and this is median. Let's save it and run it. And I have the mean and the median order amount. Similarly, we can get min value, order amount dot min, min order amount, min value. Similarly, max value equal to order amount data dot max, print max order amount, print max value. We can also do standard deviation equal to order amount dot std and print standard deviation of order amount equal to std dev. Okay, now let's run it. There we see all the results. Now, the next thing we will learn is perform descriptive analytics using the describe function. So descriptive statistics, descriptive stats equal to order amount data dot describe. So it will do multiple things, and we can just print descriptive stats. Save it and run it. So you see, this output is coming from this last print function. So it did the count 25, mean, standard deviation, min, and 25th quartile 1, quartile 2, quartile 3, and max. Then step 4 is to create a box plot. And for that, that's the code. We'll save this and run it. And there's a box plot it just created. Step 5, create a histogram. It's the code for creating a histogram. Save it and we run it. And there's a histogram. There's a box plot, there's a histogram, and here's all the descriptive statistics. So that completes this code. Now all we have to do is change this small to medium, and it will run it on a million rows of data. Save it and run it. So see, right now the count is 25. Now when we run it again, the count is a million. Count is a million, and we have a different histogram and a different box plot. And now we can make this big. So Excel can never handle such a large data set. And we run it. See, it's taking a little bit of time, but boom, I got a million records. And if I want to change the number of bins, because I have such large data, I may want to have, say, 10 bins. No problem. I can read the data all over again and recreate a histogram with 10 bins. Okay, so that completes this lesson.